If you haven't already printed out the CST review, you're going to need the first 4 pages, I believe. So if you haven't already done that, print it out right now and then start the video again. And I'm going to start with another chemistry pickup line. This one's really awesome. You must be made of uranium and iodine because all I can see is you and I. Oh, chemistry pickup lines, you are the best. Okay, so I am going to zoom in here a little bit. Zoom in. Oh, why isn't, there we go. There we go. Okay, so 1A, we're going to write down, students know how to relate the position of an element in the, I'm running out of room, periodic table to its atomic number and atomic mass. So you guys know that the atomic numbers go up, 21, 22, 23, 24, 25, 26. And notice how they go across like this. You know this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You know the periodic table goes from left to right. So that's all this is saying. So the question here tells us to fill in each atom on the table based on its number of protons, which is the atomic number. So if beryllium is 4, that means that we can figure out where he is by just counting on the periodic table. So 1, 2, 3, 4. There's beryllium. If arsenic has 22 protons, then we count like so. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So there is AS. Magnesium has 12 protons. So we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there would be magnesium, Mg. So why don't you go ahead and work on lithium, nitrogen, and sodium. And we're going to check those when you guys come into class on either Monday or when we start the review. And next up, we are going to label each as the atomic number, atomic mass, and number of protons. So the number at the bottom is the atomic number. That is equal to the number of protons. The number that's the bigger number, the number on top, that is the atomic mass. Notice it is massive, quote, and it is always the bigger number of the two. So our atomic number is the number of protons, and the bigger number, the atomic mass, that is what usually goes on top. Moving on to 1B, students know how to use the periodic table. I'm just going to say PT to identify metals, semimetals, which are just metalloids, nonmetals, and halogens. Okay, so we just wrote that down, and we're going to go ahead and do that on, what's it called? On Wednesday. But actually, let's go ahead and write in our zigzag. So the zigzag starts here and goes like this. Moving on to 1C, students know how to use the periodic table to identify alkali metals, comma, alkaline earth metals, and transition metals. So, don't do B and C. Don't go through and do them. We're going to do them in class together because we're going to be coloring some stuff. So moving on to the second page. This is still part of 1C. And it has to do with our friends, electronegativity, ionization energy, and atomic radius. So I'm going to say electronegativity is, quote, the want to add an electron, therefore becoming negative. And of all the elements on the periodic table, fluorine has the most electronegativity. Remember, we have a periodic table. Fluorine is at the very top, and electronegativity and ionization energy, they increase towards this F. And fluorine has the most electronegativity because he only needs one more electron to look like neon. And then ionization energy is the energy required to remove an electron. Ionization energy as well. Fluorine has the very most ionization energy of all the elements. And that is because he wants an electron. Fluorine really, really wants his electron. Okay? He does not want to give it up. Okay? And last but not least, what has the largest atomic radius? Think atomic radius with an R in it. That is going to be francium, F-R, because it has radius in it. Okay? And 1D, students know how to use the periodic table. I'm just going to say PT to determine the number of electrons available for bonding. So what they mean by electrons available for bonding, that's just valence electrons. And we could use our periodic table that we get to use on the CST, which is this guy here, to figure out valence electrons. It's just the A's, 3A, 4A, 5A, etc. So I'm going to go ahead and I am going to label that on the top of this periodic table. So column 1 is 1A, then we've got 2A, and we skip on over to the next tower, 3A, 4A, 5A, 6A, 7A, and 8A. So I will let you go through. So aluminum, I'm just going to write in where these are. So aluminum is right here. And chromium is right here. And potassium is right here, third one down. I lie. Potassium's the fourth one down. Lithium is the second one down. Sulfur is this guy right there. Silicone is this guy right here. And barium is this guy right here. Okay, so what I'd like you to do is go ahead and figure out how many valence electrons each of these has. Actually, for chromium, you can't figure it out because it's a transition metal. Can't figure that guy out. 1E, second to last one we're going to do, I think. So 1E says students know how the nucleus of the atom is much smaller than the atom itself, comma, yet contains most of its mass. Okay, so here, this will probably sound familiar. So let's draw a teeny, teeny, tiny little dot and a big circle around it. And this, we'll put some electrons around the circle. Okay, this guy right in the middle, that is our nucleus. It is very small and has most of the mass. The key idea here is that it is very dense. That is what they usually use to describe the nucleus as. Let me check our time. What's going on with time? Okay. Okay, we're just going to fill one more thing in. Students know atoms combine to form molecules by sharing electrons to form covalent or exchanging electrons to form ionic bonds. Okay, so ionic is the transfer of electrons. It's a single-headed arrow. Covalent is the sharing of electrons. Covalent bonds have the double-headed arrow. And just to recall, ionic bonds are a positive, a metal, and a negative, a nonmetal. And then covalent bonds are two nonmetals. Just to remind you, co in covalent, co means to share, and valent is valence electrons. So it's basically telling you which ones are, or what the word means, covalent, sharing valence electrons. And we'll end there. Make sure you bring the CST review on Monday because we are going to go over it and finish 18.5. Hope you had a wonderful weekend. Bye.